is time for our Boulder Rotary Zoom meeting, number 8, to commence. And welcome to the Boulder Rotary Club this Friday afternoon, May 15th. And we're going to start, as we normally do, with a pledge. And the person that's going to lead us in the pledge is one of our newest members, Vipul Seth. Take it away, Vipul.
Okay, thank you very much. I will try my best. I pledge allegiance to the flag of the United States of America
and to the republic
for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Now lead us in the four-way test.
The four-way test of the things we think, say, and do. Is it the truth? Is it fair to all concerned? Will it build goodwill and better friendships? Will it be beneficial to all concerned?
Well done, Vipul. I don't think I learned that until just before my presidential year started, at least by memory. So we've got a great program today, and it's a kind of a tribute in a way to second chances, because today's speaker, Matthew Shupe, was supposed to speak to us on March 13th, which you will recall is the first in-person Rotary meeting where we had to cancel due to COVID-19. So, and in a way that only Zoom allows, Matthew is joining us from Germany, where he is quarantining. But I don't want to steal too much of Bill's thunder. So we will have our presentation from Matthew, and then we will have an announcement video from the illustrious Brown family, who I see brought their dog to watch today. And then we're going to have a membership poll. And don't be scared. I think it's going to be 4 questions. And you may recall we did one of these kind of polls on April 24th. And so it'll be a similar type of format. And then today we're going to have a musical performance from Annie Booth. And that'll be at about 1 o'clock. And then we will adjourn formally at 1:15. And I will stay on afterwards to listen to your comments or mute you or whatever if you don't have a nice comment. But I know we all have nice comments. So I am now going to turn over the mic to Charlotte Rome, who will introduce one of our newest members. Charlotte.
Thank you. Do we have a slide? Wonderful. So Jim Radowski and I are so pleased to be sponsoring Vipul Seth as a new member of our Boulder Rotary Club. Vipul and his wife Madhu came to the US from New Delhi, India in 2000 when his former company Ericsson HP Telecom relocated them to Denver. They own the Gourmet Kitchen Catering Company and Copperleaf Gardens and Event Center in Broomfield, as well as Viva Productions, a Lux Indian wedding planning and design. They take great pride in providing authentic, multicultural experiences to their clients, including food, presentation, and decor. Vipul and his family love to experience different cultures. Their most favorite travel destinations are Mexico and Hawaii, but they love traveling to new places all the time. Vipul and Madhu firmly believe that socially and environmentally responsible small businesses are the solution to all the world's problems, and they believe in making the world a little better than what they found it. One example, their support for the Feed the Frontline initiative through their catering company. When one orders a meal for a frontline professional, the gourmet kitchen will double the number of meals ordered. And every time one orders from the gourmet kitchen, they will donate 5% to Doctors Without Borders, A Precious Child, Leuven Arms Animal Sanctuary, or a charity of your choice. Clearly, Vipul is a Rotarian, so please join us in welcoming him into the Boulder Rotary Club. Thank you.
Thank you, Charlotte.
Thank you, Charlotte, and welcome, Vipul. All
Thank you,
right,
John.
let's move to Bill Anderson to introduce today's speaker and program. The luckiest man in Boulder Rotary, Bill Anderson.
How many of us can say that one of the occupational hazards we face is attack by a polar bear? Our speaker today can. Dr. Matthew Shupe is a distinguished climate research scientist at the University of Colorado and the National Oceanic and Atmospheric Administration. Dr. Shupe is a leader of MOSAIC, the multidisciplinary drifting observatory for the study of Arctic climate. This year-long expedition brings together an international team of scientists studying the climate utilizing a German icebreaker ship as home base. To be sure, COVID-19 has complicated the mission. Dr. Shupe comes to us today from Germany, where he has nearly finished a 2-week quarantine before returning to the Arctic to rejoin his team. Dr. Shupe will give some insights into this important climate research and perhaps even divulge the location of Santa's lair. Before I turn it over to Dr. Shupe, just a reminder to please post your questions in the chat at any time during the presentation, and we will recognize folks after the presentation during our question and answer period. Please welcome Dr. Shupe.
Okay, thank you very much. Thanks for having me. I'm going to get my screen shared here. Can you just confirm for me that that all looks good on your end? All right, thanks for the introduction. Yeah, I'm Matthew Shupe, and I am here locally in Boulder at the university and NOAA. And I want to talk a little bit about some adventures in Arctic research and kind of culminating in this MOSAIC project that Bill mentioned. And so we'll get right into it. Let's see here. Just starting by looking down on the Arctic system. So this is the Earth from the north, and what we see around the Arctic is a bunch of land. We see Russia, we see North America, there's Alaska and Canada, Greenland, Scandinavia, and that all surrounds the Arctic Ocean. And one of the key features, of course, of the Arctic is what's called the cryosphere. It's all the frozen surfaces. So we've got permafrost on the land and lots of snow, ice sheets on Greenland and elsewhere, and of course the Arctic Ocean is covered by sea ice, and that's a really important part of the Arctic system. And the Arctic, of course, we've all heard in the news, is changing pretty rapidly. You know, the decline of the Greenland ice sheet is contributing to sea level rise. Permafrost is melting. We have lots of coastal erosion affecting communities, changes in the ecosystem. Of course, polar bears are threatened, and so many other aspects of a changing Arctic system. But perhaps none is a bigger, more indicative symbol signifying this change, you know, fingerprints of Arctic change than the sea ice. And sea ice extent is a really big kind of metric for us to understand how that change is playing out. So I'm showing here a couple diagrams from the National Snow and Ice Data Center here in Boulder that show the spatial extent of sea ice in September. Now, September is the end of the melt season, so this is the time of year when the ice is its least spatial extent. And this is an important metric for us to understand the state of the Arctic system. So in these diagrams, I put the dates on each one so you can kind of see which years we're talking about. And the white is the actual observed spatial extent. And the little pink line is this multi-decadal mean. So this might be what we would expect the sea ice to look like at the end of September. And you see in the year 2000, maybe it was pretty close to what we might expect from a multi-decadal time period. But certainly since then, we've seen many years where the ice is very much melted back from what we would expect. And up in the upper right-hand corner, this was last September, 2019. We see big areas of open ocean where we might otherwise have expected ice in the past. Now, I've put up another plot here that this is a collection of simulations from models. These are models from all the best modeling centers all around the world that are projecting what's going to happen in the Arctic. So you can see here, this goes from 1900, so from the past all the way through to 2100. And these are the projections of that September sea ice extent. And we see some observations on top of the diagram. These are from satellites. So we see a couple key features here. One is that the ice is in fact declining, and it might actually start to decline more rapidly as we go forward in the coming decades. So we might actually get a September where we see no ice in the Arctic coming up here within a couple decades. Another key feature is that we see all these different curves, right? These represent the best models we have from all these different nations around the world. And we see a lot of differences between these models, a big spread. And that suggests that there's just some basics of the system that we don't understand. We're not capturing very well in our models, leading to this big spread in how we predict the sea ice. And this is actually the case for so many other parameters. I study clouds myself, and clouds are a huge challenge for these models that we use to understand our climate system as it goes forward. Another key aspect of the Arctic system is what's called Arctic amplification. So we all know that the Earth's system is warming, and this diagram here from NASA actually shows that. So what we're seeing here is a few decades of data, about 60 years of data you can see on the bottom axis. And then what these are what are called zonal average temperatures. So this is if you take a latitude band and average up all the way around the Earth. So on the top of the plot is the Arctic, and the center is the equator, and the bottom of the plot is Antarctica. And what you see as we move right in the diagram is some yellow appears, and this is warming. These are average warmings by, up to a degree, a small amount across the globe. But what we see also here is the orange and red that appears in the Arctic. These are temperature changes of multiple degrees, 3, even up to 4 degrees in the Arctic. So this is what we're seeing is an amplification of temperature change in the Arctic relative to the rest of the globe. And that's really important as we think about the Arctic and its change. So why do we care about the Arctic? Well, the Arctic, with this declining sea ice, is really opening for so much business, cargo shipping could potentially go through the Arctic, resource development, fisheries are changing, ecosystems are changing. Considerations as the Arctic is opening, and we're going to be increasingly using it. And then how about the weather? This is actually where a changing Arctic could be affecting us all back home in Colorado and elsewhere. So I told you about this amplification of change where we see warming temperatures are more extreme in the Arctic relative to lower latitudes. And that temperature difference spatially actually drives the large-scale circulation. It drives the jet stream. And as that gradient in temperature decreases, because the Arctic is warming faster, there are a lot of hypotheses about how that's going to affect the large-scale circulation and the jet stream, suggesting that perhaps the jet stream will slow down, and a slower jet stream might meander more north and south, which could bring more warm air from the south up to the Arctic and exacerbate the changes there, but could also bring more cold air to lower latitudes and affect us. So this is things like deep freezes in Florida or Snowmageddon that happened in Washington, D.C. a few years ago. So it really brings a lot of potential variability that could affect us in our homes. So on that backdrop and in that context, I want to jump to look at a little bit of my research over the past years in the Arctic. And I'm just showing here on this map of the Arctic, the places that I've been doing research in northern Alaska, northern Canada, on top of the Greenland ice sheet. And all these little squiggles out over the Arctic Ocean are little cruises where we take icebreakers or other ships and sail through the Arctic to go make measurements, to look at this changing climate system. So I've been all around the Arctic, and I really want to focus now on this new expedition that we're right in the middle of called MOSAIC. So MOSAIC is the multidisciplinary drifting observatory for the study of Arctic climate. And it is a year-long project that started last September. And we're largely motivated at MOSAIC by the science question that I've listed at the bottom of the figure there. What are the causes and consequences of evolving and diminished Arctic sea ice cover? So the causes side of that really gets at the processes responsible for this declining sea ice. And the consequences then would be the implications of that change on the rest of the system, on our ability to predict weather, on the ecosystem, and so many others. So our MOSAIC plan is kind of depicted here. We've taken this polar stern icebreaker. It's a fantastic research vessel from Germany. Last September, we sailed away from Norway, headed out into the Arctic sea ice, and plugged that ship into the ice, and then left it there to freeze in and drift. Around that ship, we installed a lot of assets out on the ice to provide some spatial context. And then over the course of the year, we're right in the middle of it now, that ship is drifting with the Arctic sea ice across the central Arctic. And this is just the natural drift of the ice. So we're just going with the flow. Over the course of the year, we'll have a lot of resupply, bringing fuel, exchanging personnel, bringing food with other partner vessels. And we'll have some aircraft missions that will also fly around, providing some scientific measurements and other activities. So MOSAIC is very much a multi-scale activity. We have very intensive observations on our central observatory. This is the ship and equipment that's on the ice right near the ship. This is the most sophisticated experiment in the central Arctic that's ever been accomplished. And it's really because we have this fantastic ship and all these new and sophisticated sensors that are on board the ship that can make very detailed measurements, many of which we've never made in the Arctic before. So these kinds of observations are looking at processes, and I'll get into a few processes in a minute. Around our ship, we have the next scale of activities, and this is what's called our distributed network. It's a distributed network of buoys and other sensors. We fly helicopter missions around. We have unmanned aircraft providing some spatial context around this drifting ship in the Arctic so that we can understand what the variability is in the system, and so we can represent that variability in our models that have to ultimately tell us what's happening to the Arctic system. Our third level are what we call Arctic-wide linkages. This is the interaction between our observatory and other observatories at land-based stations in the Arctic, or satellites that are drifting overhead, or other research vessels that are in the Arctic. So linking what we're seeing in the central Arctic with the pan-Arctic perspective so that we can really upscale to a more global perspective and link with those global questions that we have concerning changes in weather and other processes. So just a little diagram here of some of the MOSAIC science that we're going to study and that we are studying. This is kind of a cross-section of the system, and I'll click through a number of the kind of processes that we're targeting. We're looking at ocean circulation and mixing processes. Of course, the sea ice is so important. We're looking at snow on sea ice, the movement of sea ice, how the ice breaks, how it freezes, how it melts, the atmosphere with clouds and aerosols and radiation, precipitation. We're interested in energy and momentum and humidity fluxes, both into and out of the Arctic and vertically within the system. And we're linking with the ozone layer and upper atmospheric processes. We've actually had this record ozone hole this year in the Arctic. Down in the ocean and ice, we're looking at the ecosystem, population dynamics, primary productivity, and links to biogeochemical fluxes, processes like the carbon cycle, and a lot of other chemistry that happens in the ocean, in the atmosphere. And all these processes are interacting in the Arctic system. So many different linkages here. And that's really the essence of MOSAIC, is that we're looking at these processes and how they work together in a very complex puzzle in the Arctic system. So Boulder plays a huge role in MOSAIC. We have a lot of different projects funded for doing coordination activity and communication, for looking at the thermodynamics and dynamics of sea ice, looking at gas exchange at the surface, flying unmanned aircraft around to look at spatial variability, and looking at the atmospheric drivers of the Arctic energy budget. Altogether, about $20 million of direct and indirect funding supporting these ideas that are coming out of Boulder. And so I want to spend a couple slides here just looking a little bit at some of my own science. We'll get to a slide in a couple slides here that actually shows some data, and we can talk about that for a minute. So I'll ask you to hold on as we dive into some science. This is a sled system that we built to look at surface energy budgets. So the energy budget is basically all the different terms that transfer energy between the atmosphere and the surface. And of course, you can imagine that would be really important if you're interested in understanding the ice melt or other changes in the ice. And these sleds have all kinds of different sensors built on them that measure turbulence, they measure radiation, they measure temperature. And together with these parameters that we measure, we can derive all terms of this energy transfer process. And one of the really important energy transfer terms is radiation. And I myself am very interested in clouds and how they affect that. And so here's just a schematic that kind of shows how clouds affect what's called terrestrial radiation. This is radiation that's emitted by the Earth and by the atmosphere. And this is kind of a simplified version. This is the wintertime version where we don't have the sun. The sun's not part of our equation here. This is just terrestrial radiation. And when there are no clouds, like on the left-hand side of the diagram, the Earth's surface emits radiation to space. It emits that radiation, and the atmosphere sends back to the Earth relatively less radiation. The atmosphere is relatively thin in terms of radiation. Now you add a cloud to that scene, and the atmosphere becomes much thicker, right? Our eyes tell us that. The atmosphere is thicker when there's a cloud there, and so then in that case with the clouds, more radiation relatively is sent back down toward process plays out. So there's a couple of diagrams here, and I know that it could be challenging to piece through, so we'll step through some of the details here so we can get a feel for some of the great measurements that we're making at MOSAIC. So on the left here, I hope you can all see the little pointer arrow that I'm moving around, is a distribution of the net long-wave radiation. This is the terrestrial radiation that's emitted by the Earth's surface, by the atmosphere, and you see there are three curves there. We have three of these sleds that I showed you out there making measurements. And we see that there are two bumps in each of these distributions. These are just probability density functions showing you how this parameter in units of watts per meter squared, so energy per area at the surface, how is that parameter distributed over the winter season out at MOSAIC? So these two nodes in this distribution, one around -50 and one closer to 0. And these are those cases with no clouds versus those with clouds, right? In the no cloud case, we have a big negative number. The surface is cooling to space and not much radiation is coming back down. So that's a big deficit of energy. On the other hand, this other node in the distribution is more in balance, right? We have clouds there. So when the Earth's surface cools to space, the clouds send back a lot of that radiation to the surface, and it's relatively in balance. So now we take the data from these two different nodes and we separate it out. And let's look at some other parameters. And so in the top right, this is looking at surface temperature. And the red statistics here are when there's clouds, and the blue ones are when there's no clouds. And we have three stations. So I've got the 1, 2, 3 there. And each of these little funny diagrams, they're called box and whisker plots. They show the statistics of the data. The little symbol is the mean value. And the whiskers that extend off to the side are basically the range of the data for that subset of the data. So what we see right away is a big difference between the red ones and the blue ones, right? The red ones are warmer in surface temperature by, depending on site, by 5 to 9 degrees Celsius. So indeed, the clouds are acting as a blanket for the surface and warming the surface by adding more radiation down to the surface. And then another interesting one, and hang on with me here, it gets a little more complex, is in the lower right-hand corner. And what this measurement is a surface heat flux. This is basically quantifying the amount of energy that is coming up to the surface of the ice from below. So you can imagine that out in the Arctic, you can see that temperatures there at the surface are in the -20s. They're pretty cold. And of course, the warmest thing around is the ocean water that's below the ice. It's not frozen yet, so by definition, it's around 0 degrees Celsius. So that's the heat reservoir, and that heat conducts up through the sea ice in a process that helps to form that ice in the wintertime. The more heat that conducts away from the bottom surface leads to freeze up. So let's look again and partition our data into those cloudy scenes and those non-cloudy scenes. And it turns out that at each of our 3 stations, we have 2 different sensors like this. But you can see the statistics then. These box and whisker distributions again show a separation. And when the clouds are there, we see less of that transfer of heat upwards through the ice. And when there are no clouds, we see more of that. So to bring it all together, we have clouds that come in. When those clouds come in, they warm the surface, they decrease the amount of heat that conducts up through the ice, and they slow down the ice freeze up process. So it's a really interesting, what we call coupled system, interactions between different parts of this complex Arctic system. So by the numbers, MOSAIC has 20 nations involved. We have 7 icebreakers or other ships engaged with 60 institutions, and more than 400 people will be out in the field in support of this mission, with a $150 million total budget and about $40 million for the US side of things. And so with that, I just want to end with a few pictures from the field. I know people really like pictures, and it really will help to bring you there to our expedition. This was a shot early on as we started to adventure into the ice pack with our ship there, full of scientific equipment. We arrived in the central ice pack and started to explore some ice flows to find a home for the next year. And this is our first adventure there. I'm leading a team out to go make some thickness measurements to see if this is a suitable ice flow. Of course, we're met by polar bears and many other interesting critters that are curious about what's going on. This mom and cub stuck around for a few days as they were kind of checking out of what we were doing, and I'm sure we smelled really good to them. At that point, we started to set up all kinds of equipment. We built some shelters on the ice. We set up some towers. Here's a tower from one of my projects that we led in Boulder. Here I am putting some instruments on that tower. You can see that it's starting to get dark. We were really racing the sun because we're falling into the Arctic winter with complete darkness for 4 months. So we were racing the sunlight. Here's a nice picture of the outfits we wear. We've got these nice red suits that float if you fall in the water and that keep you warm. We use helicopters a lot to go out to our distributed network to maintain our equipment there, so lots of helicopter activities. Here's a great shot from a colleague of mine of one of our sleds out there. You can see this starry night. Of course, this is a bit of a long shutter, but it really just remarkable scenes out there in the Arctic. This is a scene from what we call Met City. It's one of our cities of instruments out on the ice. That bright light in the background is the ship and its lights. And this is the kind of scene that this is the middle of the day. This is in the wintertime, it's dark in the middle of the day, and it's windy and snowy and kind of blizzardy, but this is a typical day at the office out there in the Arctic. We of course have a lot of cracks. There's crack emanating here from the front of the ship. And right now our colleagues on site are really struggling with a lot of cracks that are threatening some of our measurements at the moment. And sometimes we have to makeshift bridges and what have you to navigate through the ice to get out to our research stations and other equipment on the ice. And sometimes the ice wins. This is one of our sleds that got upended by this pressure ridge that formed. Some northern lights, typically we're too far north for the northern lights, but occasionally you get some of that. And here's a great shot of the about 60-person research team we have out there, all dressed up in our suits. Then, in December, another ship came out to meet us. So there's 2 ships next to each other, and we rotated crew, and I was on my way home then. This is out by the ice edge, this fantastic pancake ice formation. You can imagine the swell flowing through the Arctic Ocean with all these little lily pads of ice floating. Pretty remarkable scenes. And that brings me to the end of my presentation. This was the scene as we left, total darkness throughout the whole day. And now I'm on my way back. We're here in quarantine, ready to hop on a ship to head out there And at this time of year, it's the opposite. Right? The sun circles the sky. It's light all day long. The melt season is about to start, so we'll get a lot of transformation of the surface, and it's really exciting to get out there and kind of carry in this mission. And I give you some information there about how to keep track and keep tabs on MOSAIC. It's really exciting, lots of great web content, and keep an eye out on the Fisk Planetarium schedule, because eventually we'll have a planetarium show there that we're filming out at MOSAIC that can help to bring you into the scene. And with that, I'll say thank you to y'all and happy to answer your questions.
Thank you, Matthew. That was fantastic. We've got a bunch of folks have submitted questions. I'd like to start with John Kotke, if he can be unmuted.
Matthew, that was absolutely fascinating. One of the questions I had early on in the presentation, you showed the slide that the Arctic is warming faster than the rest of the Earth. Everything is warming, but it's more rapid there. What is the explanation, or is there an explanation for that?
Yeah, Arctic amplification, we have a lot of research that's going into that question right now. This is a great mystery for us. Although we are gaining some insight, and one key aspect of this is what's called the ice albedo feedback. And so this is a process whereby as the system warms, the sea ice melts back, and the sea ice, of course, is very reflective, so it reflects a lot of sunlight back to space. As that melts back, it exposes open ocean, which is dark and absorbs more solar energy, which warms that ocean and melts more ice. So you can imagine this cycle, this feedback that really amplifies that warming signal. And that's something that's pretty uniquely happening in the Arctic right now.
Thanks, Matthew. I see the next question is from Meryl Glustrom.
Thank you, Matthew, for speaking to the club. And I really appreciate that you've kind of emphasized that it's a very complex system with lots of variables. So I'm just going to focus on one of them that's of interest to me, and that's the permafrost. And as the system temperature rises, the permafrost melts. What's the effect on the climate in the Arctic and maybe the Earth of that happening?
Yeah, this is not exactly my area of research, but there are many potential effects, one of which is related to the carbon cycle, right? So as the permafrost thaws, there's lots of carbon in that permafrost. So methane, for example, that could be released into the atmosphere, which again, methane is a greenhouse gas, and ultimately it's things like methane that can affect the overall Earth's energy budget and drive change further. So yeah, as the permafrost destabilizes, there are a lot of questions about how much additional emissions are we going to get into the atmosphere that could enhance this greenhouse-driven warming. So that's one of the questions relative to changing permafrost.
Thank you.
All right, next up, President John had a question.
I do. Thank you very much, Matthew. My question is, we've been hearing increasing instances of these polar vortices that seem to descend from the Arctic and create really cold, nasty weather. We just had one about a week ago. And the question is there a connection between these and the diminishing sea ice? And can you explain it if there is?
Yeah, I mean, that is a great question. And again, it's one that a lot of people are trying to study right now. And so this diagram that I showed is a proposed mechanism whereby there could be a connection there, right? As this kind of north-south temperature gradient weakens because the Arctic is warming faster than the tropics, the jet stream could be slowing down and meandering more to the north and south, which would be related to drawing a lot of this cold air from the north down to us in the south. So it's an interesting thing where an overall warming could actually lead to some localized cooling in our system. And really what's happening is we're getting potentially increased variability. And this is one of the biggest questions that we're attempting to tackle with our Arctic research right now, to really understand these mechanisms and evaluate them with observational data and with models that are verified using that observational data.
And I think along the same lines, Nancy Chin Wagner had a question.
Hi, Matthew. Thank you for presenting here at Rotary. Very interesting. And my question was similar to what you were just answering John's, was about the jet stream, and how it's affecting the Florida and I was just wondering, what about the other countries along the equator? Are we going to see some coldness coming through? And should people be moving out of Florida and going somewhere else?
I certainly am not going to be advising people on where they should live. That's someone else's job. But yes, there are lots of questions about what this potential change in variability might do to people. And, you know, it's something that there are teams of people working on. Lots of people at NOAA in Boulder are working on this topic. As far as effects in the tropics from Arctic change, I don't really know the answer to that. There's a lot of debate about that right now. Tropical variability is very strong on our Earth, and it controls a lot. And so some of the debate is whether or not the change in the Arctic is really just due to tropical variability itself. And so these are things that we're trying to unravel. We're working very hard to answer those questions.
Do you have a time range that you're thinking that some of this could come a little bit more relevant? 10 years, 20 years?
Well, in terms of the sea ice, you saw the plot I showed about the declining sea ice, and that's what our best models are suggesting right now. Now, you know, if that ice decline is related to changes in large-scale circulation, then you could see the kind of time scale of those kinds of effects. But again, there's a lot to study still, and we really have to make these models better in many ways to really be able to answer those global scale questions.
Right. It's amazing, that sea ice decline model. It's really great.
Yeah.
Thank you.
So, Matthew, this is Bill. I actually have a question too. In researching to prepare your introduction, I was shocked at the temperature variation at the North Pole, that in January it may average -11, but in the summertime, you guys can see average temperatures of nearly 60 degrees. And I'm curious how that affects the mission and the research. I mean, you showed a couple of photos with that pressure ridge, but does that increase the risk for researchers falling through the ice and things like that? And how do you mitigate that risk in the warm weather?
Yeah, the Arctic can be highly variable. So in the wintertime when I was there before, the temperatures were -35, -40 degrees at times. But indeed, we do have these episodes where a lot of warm air goes into the Arctic. We actually are having one right now. We had one a couple weeks ago. And this could be related to that variability we're talking about, right? Bringing more warm air into the Arctic. Right now, the temperatures out near MOSAIC, where my colleagues are getting very close to the melting point, within about 1 degree. So we could be seeing the melt onset already, which is a little bit earlier than we would anticipate. But again, these things are episodic, right? We get this storm effectively that brings all this warm air and can heat things up temporarily. And then I would guess that perhaps, next week things will be a little cooler again. But in general, we're going to transition towards the melt season and towards summer when, yes, the surface will be melting for multiple months in a row. That does pose a little bit more challenge for us doing our research. The surface will become covered with melt ponds. So on top of these ice flows, they'll start to form ponds that are liquid water. And so we're going to have to venture around this maze in order to go out to our research stations. So that will be a little more challenging. But in general, we'll be safe. We've got those great red suits that keep us afloat if we fall in, and they keep us warm out there.
Thanks, Matthew. Vipul had the next question.
Hello, Matthew. So what I see is a disconnect between what scientists see and what normal public understands. And I know that Dr. James Hansen had tried to do something to make it easier for public to understand what you're trying to explain. And can you tell me if there's an effort in the scientific community towards that to make it easier for people to understand all this, all the complexities of weather, not weather, of climate change?
Yeah, unfortunately, some of that broke up for me. I hope that our connection is good enough for everybody here. Yes, communicating climate science is a huge challenge, right? There's so much different information, complex information, and sometimes misinformation out there. And this makes it challenging to do what we do. It is very important to communicate a complex process, right? There's lots of unknown and lots of variability in the system that we're trying to quantify. And then somehow distilling that down to simple messages so that they're kind of manageable for the broader community. And so we certainly have a big effort to do that. Here at CU, we have a lot of outreach efforts, for example, where we're trying to use some of these compelling images from the field, some of these great scientists that are doing their research, and packaging that in a way that we can reach out to different communities, to K-12 education, to the general public, in ways that they can really find the information more accessible. And so hopefully through things like the planetarium show that we're going to have, that can help to accomplish some of those objectives. But yeah, it's really complicated right now to communicate these changes that we're seeing in the Arctic. But one thing I just want to emphasize is that there are certain parts of this complex problem that are not uncertain at all, that we really do understand well. And things like what I'm, on these plots on the screen right now, the sea ice is going away, right? That's something that's really not debatable. It is so clear. And it's something that I think people can understand pretty readily. The ice is going away. Now, what effect that has is more complicated, and that's part of a bigger discussion that we have to have. But as scientists, what we really want to do is provide the best information that we can to society and to our decision makers and policy makers, so that we can all make wise choices. And we definitely understand that that includes science, it includes economics, it includes many other factors to ultimately feed our decision-making process.
Thank you.
Super. Cassidy, you had the next question, I believe.
Hey, thanks, Bill. Thanks, Matthew. We were really interested in watching what was going on with MOSAIC as the COVID pandemic has started, and you got caught up in that almost right away. And I'm wondering if it has had a huge impact on the MOSAIC expedition. And also our president had a kind of connected question, which was, how many people are in lockdown with you? And thanks for being here, by the way.
Sure thing. Yeah, COVID has affected us. It has made it so that we had to change some of our logistics, some of our rotation plans. And so the people that are on site right now, including one of my colleagues from Boulder, they've been there some extra time, we'll say. And by the time they get home, it will be 2 months extra. So they're really our champions right now. So it's changed that, and it's kind of changed our approach to how we rotate people. Right now, we've got about 100 of us here in quarantine that are ready to get on some ships and head out there. We're really trying, of course, to keep the isolation. We don't want to get any of the virus out at the research facility. And if we're successful in kind of managing this quarantine process, then we can keep that ship out there in the Central Arctic as one of the safest places on Earth. So we really want to keep that in place so that we can carry on our science. Otherwise, hopefully the COVID situation will not have other major effects on our ability to conduct that research.
Thanks, Matthew. Charlotte had a question.
Thank you. Thank you, Matthew, for that presentation. So I know you mentioned that there's still a lot of uncertainty in large-scale circulation models, but I was wondering if you're measuring dust deposition in the Arctic from global sources, and how changing global circulation patterns might be affecting that, and the consequent changes that might have on radiative properties.
Wow, that's a pretty sophisticated question. All right, so you say dust deposition?
Yes.
Yeah, so we are very much interested in dust and other atmospheric particles that could affect cloud formation. That's a very important concept for the Arctic system. Understanding the sources of those particles and the effect that they have on the fractional occurrence of clouds, the phase of the clouds, the precipitation efficiency of the clouds. So yes, I mean, we certainly are measuring dust and other aerosol particles to the best of our abilities. It's a challenge to do that. Right now, we're trying to take a lot of air samples, and we're making those samples near the surface because that's where our facilities are. We're trying to expand our capabilities vertically by taking measurements on tethered balloons that go up into the atmosphere to really extend that knowledge vertically. But yeah, for our ability, we're going to characterize the aerosol particles and their effect locally on our measurements and locally on the processes that are playing out radiatively and from a cloud process standpoint.
Thanks, Matthew. Thanks, Charlotte, for the great question. Paul Jurdy.
Yes, Matthew, thank you so much for doing this. I drafted a question, and it's sort of an open-ended, perhaps not very well articulated one, but dates back to experience I had for some years at the university in an entrepreneurship program there. And we learned years ago, working with students, college students primarily, the effectiveness of having discussions about not the impending threat of issues such as scientists are studying, but rather to try to move the dialogue to what are the creative entrepreneurial opportunities, ways of changing our system, our way of life, whatever. In other words, changing the dialogue from one of the concerns of the constant threat to one of, okay, what kinds of opportunities does this engender? And I know that's not at the heart, I don't mean to put words in your mouth, but at the heart of what the fundamental scientific research is you're doing. But it seems to me that until we are able to effectively change the dialogue and to say, here are the things that we can respond to favorably, creatively, entrepreneurially, we're going to continue to have the denial discussions in the public discourse. I'd be interested in your thoughts, Matthew, on that.
Yeah, that's a great question. One aspect of this that is really of interest to me is that, you know, the Arctic is changing, right? It is going to change no matter if we would prefer it not to or if we are fine with that, right? It's changing, and this is just a reality. And so the way that we approach that is we're going to have to come to terms with this, and we're going to have to do things like predict sea ice very well, because we're going to be operating in the Arctic more and more, whether we like it or not. It's going to happen. And so that's an interesting thing, and I would really, in a way, to me, love to get past the politics angle of this and get more on this kind of same page of just being representing and understanding what's happening in this changing Arctic system, right? In the end, it doesn't matter to me necessarily if you're a person that wants to kind of preserve the Arctic in its historic state, or if you want to go and drill oil in the Arctic, right? There's many different things that are kind of on the evolving plate of the Arctic, if you will, that I think we all across our society can hopefully agree that we just want to understand better. We want the best information that we can get so that we can kind of feed into that societal dialogue that we're trying to have about the changing Arctic and really the changing globe. So I'd love to get to a state where we all value science across the spectrum. And of course, we might make different decisions based on that science, but at least we value the scientific process. And so I, as a scientist, if I can, stay outside of the politics and just feed in, the best science that we can so that we can have that societal dialogue.
Thank you.
Thank you so much, Matthew. I'd like to now pass the microphone over to Charlotte Rome again, as she is our responder today.
Thank you, Bill, and thank you, Matthew, and thanks so much for this engaging and informative and educational presentation about your work and the fascinating MOSAIC project, specifically the collaborative, interdisciplinary, multi-scale aspects of the research. I believe I speak on really behalf of all those participating in this meeting today when I say that I look forward to continue following this expedition and to hear about the research outcomes that I truly believe will be essential to inform and shape some of the critical next steps that we have to take as a global nation. So thank you. As you may know, for more than 30 years, Rotary International, in partnership and with support from the Bill and Melinda Gates Foundation, has been working to eradicate polio worldwide. Our goal of ridding the world disease is closer than ever. As of today, we've reduced polio about 99%. However, it still remains endemic in a few countries, and that's really crucial for us to continue working to meet this goal. So therefore, in your honor, the Boulder Rotary Club would like to donate 100 doses of vaccine to the Polio Plus campaign to get us one step closer to finally eradicating polio. So thank you so much again for being here today and for taking the time and being with us.
Yeah, thank you all for having me, and thanks for the great questions. It's really nice to have a scientific dialogue about how the changing Arctic affects all of us. So thanks for your great questions.
All right, I'm seeing a few of those clapping emoji hands, which means we're getting better as a group at how to run this Zoom technology. Thank you very much, Matthew. All right, we are going to see our MP4 video. Take it away.
Welcome to Boulder, Colorado. Oh, wait a minute.
All right. Okay. Go.
Welcome to Boulder Rotary, the best place to be on a Friday afternoon in Boulder, Colorado.
The Rotary Interact Clubs from Boulder High and Fairview High have decided to work on a fundraiser for Voices for Children. So instead of their usual Jam Fest, they have created a link in the rib, and their goal is $5,000 for Boulder Voices for Children. Join us in supporting them.
Join Rotary International for the first ever virtual convention, the 20th through the 26th of June, 2020, of course.
And here is your Feed the Frontlines update. Thank you to everyone for all your support for this fundraiser. We've actually received enough donations for 6 meals so far. The Boulder Rotary Club banner is up in the BCH cafeteria for the next 2 weeks. Thank you for all your support for our local healthcare workers and restaurants.
Charlotte Rome brings up a volunteer activity on a regular basis through the summer to help weed and water school vegetable gardens in Louisville and Lafayette areas. It's Garden to Table. It follows the CDC guidelines for community gardens under COVID-19. Contact Charlotte for details.
Food drive update. Our last food drive brought in 2,625 pounds. We also received $1,270 in checks that is going to be matched by St. Aidan's. And $130 of gift cards. Not too bad. So stay tuned. Our next food drive is on June 13th at the JCC. And join us for more details.
Yes.
They are screaming for you, Boulder Rotary.
And join us for next week's program on May 22nd. It's Avani G. Dilger, Natural Highs, Mental Health in the Age of COVID-19, Healthy Alternatives to Drugs and Alcohol. Don't miss it.
One of the responsibilities of a member of Rotary is to support what Rotary does. And Ted Manning and I decided a number of years ago to incentivize people to support Rotary in a better way than they normally would. And so we began to match a contribution to the Rotary Foundation that would bring you to a Rotary Fellowship, a Paul Harris Fellowship. And we decided that we would do that once a year, and we've been doing it. I've been doing it, and in memory of Ted, who passed away in 2014, we've been doing it for about 10 or 11 years. Matching half of what it takes to get to become a Paul Harris Fellow, or to become the next level of Paul Harris Fellowship. And so if you want to put in $500 to become a Paul Harris Fellow, we'll match it with another $500 coming out of our pockets. If you want to go, it takes you $300 to become a Paul Harris Fellow plus 3, we'll match that $300. We'll match it up to $1,000 per Rotarian, and hope that it will incentivize you to become a Paul Harris Fellow and support what Boulder Rotary does, what Rotary International does.
Thank you, Michael Weatherwax, for being our guest speaker on the MP4 video and for your commitment to the Rotary Foundation. Contact Michael. Every Rotarian, every year.
Have a great weekend, Boulder Rotary.
Every year.
Yay, MP4. Thank you, Daryl and Sally. Okay, well, I'll tell you what. Let's postpone the poll till next week so that we can listen to some music from Annie Booth, who has joined us from the University of Colorado College of Music, where she is a graduate assistant. And she's in the Jazz Studies program. She is a pianist, composer, and educator. She recently won a Downbeat Award for outstanding performance by a graduate. So let's connect with Annie and we'll listen to some music here for about the next 10 minutes.
My name is Annie Booth, and I just graduated from the College of Music at CU Boulder, where I also did my undergraduate work. I'm going to perform, I thought this might be a fitting composition for the work that you folks do. And this is a composition of mine that I wrote a few years ago about one of my all-time favorite places on Earth, but certainly in Colorado, the Sangre de Cristo Mountains. And this song is called Mother Earth, so it's just kind of about the beauty down there and about the beauty of our Earth. So I hope you enjoy. Thank you. It's called Mother Earth. And I thought I would continue with hopefully a very well-known song for everyone. This is kind of one of those songs that I think has just become a part of the American consciousness almost. It's one of the Great American Songbook classics from the musical Porgy and Bess. This is George Gershwin's Summertime. Thank you so much for having me. It was such a treat.
Annie, I do mean to interrupt you. We're having trouble hearing your voice. We hear the piano okay.
Can you hear me now?
There.
All right.
There.
All right. So I don't know if you heard the introduction to the first tune that I played. It's a piece of mine, an original composition I wrote about the Sangre de Cristo Mountains, which are one of my favorite, probably my favorite place in Colorado. I have a lot of dear friends down in Westcliff, Colorado, so I go down there every summer. And and that one's called Mother Earth, and I just thought that might be a nice I don't know, just kind of fitting along with the work that you folks do to preserve our Earth and all the beauty that it holds. And then that last one was probably recognizable, "Summertime" by George Gershwin from Porgy and Bess, and also maybe a fitting song as we enter into summertime.
All right. Thank
you for having me. I really appreciate it.
Okay. Well, if you'll do it again, we'll have you again.
That sounds great.
All right. Thank you.
Thank you.
Okay. Well, the time has come for the formal closing of our meeting. And some of you may be looking for a COVID-19 fix, discussion policy fix. And if you are, I have learned there is a town hall, a virtual town hall this afternoon that's focusing on Boulder County and its reopening. And there are going to be 3 of our local representatives there, as well as one of whom is our club member, Edie Hooten, as well as John Terre, who has spoken to our club, and 2 representatives of the Boulder Department of Public Health. So if you want to do that, I would go to, the thing I have says go to Casey Becker's website, and I'm sure you'll find something on it. If you didn't make it to the food drive last week at the YMCA, you have a chance for redemption this weekend because the JCC is hosting a food drive on Sunday, the 17th from 1 to 4. This particular food drive is benefiting EFA. And speaking of food drives, our next Area 11 food drive is tentatively set for June 13th. It will also occur at the JCC. And this will be the one we do with our other, our sister clubs in Area 11. And that one will benefit Sister Carmen. And there's been a lot of uncertainty in my world, and perhaps in your worlds too, with the sort of reopening. How much should we not reopen, or should we just reopen and fill the bars and restaurants? And so I'm going to remind you of something William Churchill said that I think applies a little bit today. Success is not final. Failure is not fatal. It is the courage to continue that counts. Thank you for joining us today, and our meeting is adjourned. And I will stay on, and we don't have Matthew Shupe with us, but if people want to stay on and chat, I'll stay on for a little while longer and try and moderate said chat till 1:30.
And we're meeting next week.
Yes, we are meeting next week. Same bat time, same bat channel.
I just wanted to say thank you so much for a wonderful meeting. This was a really cool one to start out with. What a wonderful discussion and wonderful presentation. And I look forward to joining in next week as well. So thank you very much for having me.
Thanks for being here, Monica.
Yes, and I wish we could put you up on the stage in front of the whole club, but
soon enough, soon enough.
Soon enough, right.
Wishing everybody a good week. Until next time.
So Henry Lopez is still on. I have a question for Henry Lopez. I really have to know what that picture is in your background. It looks like a fabulous interior of a cathedral.
Is it the Blue Mosque?
Actually, it is. It's the it's Hagia Sophia that was constructed, I believe, in 532 to 537.
Yeah.
In then what was known as Constantinople, which is now Istanbul, which is that one sound that came out some years ago. But anyway, it was the largest church now at that time until St. Peter's was constructed. It survived the It's getting close to over 1,450 years old. As you can tell from what's on there, it's when the Muslims took over the city or the country, they turned it into a mosque. It was a church for the Eastern Orthodox Catholic from when it was constructed to about the 13th or 14th century. And then it became a mosque, and then it became a tourist place in the early 1900s. So it's no longer a mosque. And they've left some of of course, the Muslim religion symbols up. They have uncovered in one of the domes painting of Mother, the Virgin Mary with Jesus as a child. And to tell you a little bit about it, is the first use of arches and buttresses. It's got, the main dome is supported by 4 arches, and the way it's supported at the corners are called pendentives, and they're supported for the outward thrust by pilasters that are not pilasters, but the pendentive arches are what's supporting the outward push. Anyway, I actually put together a program on it, about 15 minutes long, on Hagia Sophia. It's really a neat structure. That dome has collapsed once from an earthquake, and it was reconstructed 40 feet higher. Anyway, that gives you a little bit of idea of what it is.
Thank you. It's been like attracting me for weeks. So
yeah, the picture from the outside shows you, really gives you a much better idea how big it really is. Although now, when you see a picture from the outside, you'll see 4 marionettes that were obviously added when the Muslims took over.
All right.